Hello and welcome to part 2 for the second example, part 2. So technically this is part 4. Sorry, so part 4, but this is the second example, multiple linear regression. So for this one, we're going to look at the research question, how do exercise, optimism, and age influence a student's midterm grade? So once again, remember, influence, even if the research question says influence, it means prediction. And it's going to be a multiple regression because you have more than 2 variables, right? So make sure when you write out your hypothesis that you write prediction, even if this says influence, you know, right? Because you're all smart and amazing, that it means prediction and that it's going to be a multiple regression because all of these variables, right, are numeric. And you're like, wait a second, how is optimism numeric? Now, if you're not sure, you're like, wait a second. Well, first of all, seeing influence should be a clue. Seeing the, more than 2 variables should be a clue. Okay, this sounds like it should probably be a multiple regression. But what you can always do is come over here and look for optimism and be like, oh, okay, so like optimism isn't low, medium, high. It's 17, 21, right? So that's numeric, right? It's listed as a scale variable. So I am good. All of those are numeric. So once again, null, no significant prediction. Alternative, there is a significant prediction. So let's go ahead and do this one. Remember, we're going to come up to regression, linear regression. And in this case, right, there's no significant prediction of midterm grade. So our dependent response variable is going to be midterm grade. Oops. And we'll pretend that we checked and made sure that all of these variables are scale. Because remember, all of them need to be listed as scale, which means numeric, in JASP in order for you to use them. So we'll pretend we did that. So midterm grade, right there. And then we're checking it, right? Not checking it, but we're thinking that midterm grade can be predicted by exercise and optimism and age. Now the big thing here, and I didn't say it in the last video, is that it doesn't matter what the order is, exercise, optimism, and age. I like to put them in order of how they were listed in the hypothesis, and that's just because for me it keeps it easier to keep track of them. But ultimately, the order of the covariates does not matter. You're going to get the same ultimate p-value and f-value and all of that. You'll even get the same, basically all your values will be the same. It's just the order will be different. So I just wanted to throw that out there. I forgot to say that. So if you're like, oh my gosh, maybe I put those in the wrong order, there is no specific order for covariates. Now, the dependent response variable does have to be up there, and that does have to be correct, but otherwise the order of your covariates does not matter. Okay, so now that we've got these results, let's go ahead. Remember, our main multiple regression results are in this ANOVA table, and we have that p-value of 0.229. Now, when we're thinking about it, is it less than or equal to 0.05? No, that is significantly bigger than 0.05. So this is not a significant p-value, right? So we fail to reject the null. It's not a significant p-value. So right off the bat, in terms of our results, the p-value is not significant. So the results indicate there is no significant prediction of midterm grade by exercise, optimism, and age. We fail to reject the null hypothesis. So basically this means nothing's happening, nothing's going on, right? You cannot predict a midterm grade by how much someone exercises, their optimism level, and their age. Nothing happening. When you're writing this up, remember your degrees of freedom, your F value, then your P value. Make sure and italicize that F and that P. Let's go ahead and take a look at the rest of the results. So once again, even though we don't have significant results, we're going to go ahead and talk through the rest. Oh, you know what we forgot? Oh my gosh. We forgot that Durbin-Watson value. See, you all weren't here to remind me. I'm sorry, not blaming all you, but one of you probably would have reminded me because you're all amazing like that. But okay, so when we add that Durbin-Watson, you can see that the Durbin-Watson value is good. So remember the Durbin-Watson right here, it checks for that correlation between the residuals, which can evaluate the regression. It should be above 1 and below 3. So that's actually okay. Which is good because that means that our results are legit. So And that's important to recognize that even if we don't get significant results, it doesn't mean they're wrong. It just means that's what they are. And sometimes it's important to know like that these things don't contribute to this. And in this case, that Durbin-Watson value is just helping validate that our results are accurate. If our results had been below 1 or above 3, then we could have said, well, we didn't get significant results, but because the Durbin-Watson value wasn't valid, there could be a potential issue. We would need to go back, double check things, blah, blah, blah. So in this case, that Durbin-Watson value does validate the results that we got, which, it's good, right? Because we want valid results. Then remember, the other things we're going to look at are going to be this coefficient table. The adjusted R-squared. That probably should be first. So the adjusted R-squared is that 0.05. What that means, because remember you multiply by 100, is only 5%, right, of the variation in midterm grade can be attributed to exercise, optimism, and age. That's extremely low. So if we come over here, right, and that 5 falls into poor. So yeah, not good. A poor amount, 5% of the variance in midterm grade is explained by exercise, optimism, and age. So yeah, basically nothing, right? It's extremely small, very poor. This is also, remember how I said, this is how you can't have nonsense results, because they're letting you know, like, that's only 5%, or, if it was worse, it could have been 0 or 1. But overall, these are pretty not great results, which kind of supports the fact that our p-value was not significant, right? So these just kind of go hand in hand together. And remember, italicize that adjusted R-squared value and make sure to add in that poor amount, 5% is not explained. Okay, now we can get to the coefficient table. So you can see that our intercept is 82.618. Then we've got exercise, optimism, and age. Now, if you look over at the p-values, you can see that exercise, 0.058, it was 0.008 away from being significant. So in this case, exercise was clearly probably the best right predictor. So even though it wasn't significant, I find it very interesting that exercise was probably the best predictor for midterm grade, where optimism and age, like, no, those p-values are like blah, right? Nothing going on there. So even though this exercise still is not significant, it was 0.008 away from being significant. Heck, if we just had, maybe a few more participants, exercise might have been significant. So that's kind of cool. And then in interpreting these unstandardized results, remember that exercise and optimism, right, because they don't have the negative sign, that means it's positive. So that means the more someone exercises, the higher the midterm grade. Optimism would be the higher the optimism score, the higher the midterm grade. And age, right, has that negative relationship. So in this case, the younger someone was, the higher the midterm grade. Or the older someone was, the lower the midterm grade. Now, once again, none of these results were significant, though. I just want you to understand what those variables mean. Now, if they were significant, they would mean a lot more. But since they're not significant, it still ultimately means there's really nothing happening here. Exercise is probably, like I said, the most interesting because it's so close to being significant. Something else, if just one of these predictor variables is significant, you will have a significant overall model. So if this exercise was significant, then this p-value would be significant. That's just the way it works, that if you have at least one significant predictor, you will have an overall significant model. Even if you only have 1 out of 3 significant, you will have a significant model. So that's kind of important to recognize that if this p-value is not significant, this overall model p-value is not significant, you just automatically know that none of your predictors are significant, because if at least one of your predictors was significant, your overall model would be significant. So just a little kind of fun fact there. So going here, so once again, right, so we've got remember that y hat in this case is that response variable. So that's your midterm grade, and that's equal to the 82.618 and then minus zero point 0.7, oh, see, and age, optimism, exercise. So obviously I put them in a different order here. But it is negative for age, 0.174 age, plus 0.393 optimism, plus 0.361 exercise. And if you really wanted to test this out, which I don't think I even bothered to test this out in this one, but I mean, if you really wanted to test it out, you could always come back, and come over here and look at, if we went back 22 age, optimism score was 17 and exercise was 4. And then you could look and compare their midterm grade. But that doesn't really make sense because the model's not significant. So not even going to bother doing it because the model's not significant, and there's really nothing to see here type thing. I already explained this, and so we can go ahead and go straight to the write-up of the results. So very similar to before, the only difference was that this is not significant. So a multiple regression was calculated to predict midterm grade by exercise, optimism, and age. The Durbin-Watson value was normal, indicating a valid test. The results were not significant, and we failed to reject the null hypothesis. This is a mission-critical statement. Just that reminder, you got to have that statement. Then we've got, our APA right here, all that good information. Make sure italicize the F, the P, the adjusted R squared. Include that poor amount of the variance in midterm grade is explained by exercise, optimism, and age. Include that regression equation. And then you would just say when other predictor variables are held constant, there is no significant relationship. Given the low adjusted R squared, these variables are not good predictors and other variables should be considered. So this is an example when you have non-significant results of how you would write it up. So just so you can see, for the quiz in week 3, when you're doing a multiple regression, if your results are not significant, this is what you should be writing up. So I hope this helps. The next video, we're just going to go ahead and talk about the week 2 assignments and just kind of wrap things up.